Okay, I think we're ready. Wow. Thank you all for being so patient. And this is not my presentation. Hang with me, guys. Hang with me. Hang with me. I'm coming. My presentation didn't save before I sent it to myself. Hope everyone had a nice Easter. I did. I didn't do anything. It was great. Okay. Organise my pantry. Watched a few movies. Alrighty. It's coming. Okay, so today, while I wait for my presentation to load, we are talking about testing for Green Star credits. So the reason I wanted to do this talk today is because Green Star has some wording in there around the compartment testing, the smaller amounts of buildings that you can test. And I just wanted to clarify exactly what that means. That's really the purpose of today. I also have heard on the grapevine that some of you Green Star professionals, GSAPs out there, don't quite understand what air tightness testing is. So I wanted to reach out to you guys specifically because you are one of the few organisations around that actually have mandated air tightness testing as part of your criteria if you are going for the commissioning credits. So it's really, really important that you all understand exactly what it all means. So just excuse my inbox for a minute while I get my presentation. Oh, why? Oh, this is a disaster. Anyway, we will get there. Let's just stay calm, shall we? Third time lucky. The reason this is creating such a kerfuffle is because I'm having to use a different laptop for this presentation than I actually do my work on because the webcam on my computer isn't any good. So I'm having to use a different laptop and I have to transfer my presentation over to that laptop. Okay, here we go. Let's see. Oh, look at that. Let's download it. And let's get cracking. Okay. And here we are, ready to begin. Nothing like a bit of excitement on a, what are we? Wednesday? Is it Wednesday today? I don't know, I've lost track of the days. Okay, Green Star and air tightness presented by me. So I don't know if any of you have actually seen the presentations I've been doing in the previous weeks about air tightness testing, but for those of you that haven't, a little a quick brief recap on what air tightness testing actually is. Air tightness testing is a process where large fans are installed in temporary door frames, and the building is pressurized to 50 pascals pressure difference inside and outside the building. And this is how we measure the leakage. We measure how much air is required to pump into that building or suck out of it in order to get to the required 50 pascals, and that's how we work out the result. The number of fans we use on one of these tests is determined by the size of the building and how leaky it is. And you can have a very small building that requires a lot of fans if it's very leaky because you need more air to pressurize it, and vice versa. A large building can require not many. And I've trapped a fly in my office. Fantastic. Okay. Yeah, so the number of fans is determined by the size and leakiness of the building that we're testing. The results are worked out based on the envelope area of the building. So this little diagram here shows you the difference between the volume and the envelope area. The dark green is the envelope area, the light green is obviously the volume. So for argument's sake, let's just say the light green represents the volume of air that we need to pressurize the building to 50 pascals. So to work out the results, we calculate, before we come to site, we have a copy of your plans and we work out the envelope area of, we work out the square meterage of the envelope area in the building. It's actually streaming. I'm not getting it on my YouTube channel here, but I hope so. I'm going to carry on. So we calculate that dark green area, which is the envelope area of the building. When we come to site with our gear, then we load all the fans in external doors, and that can be quite a process actually, working out which doors to use. Because there's not always appropriate doors. So sometimes it requires a little bit of extra lateral thinking to make that work. But when we work out how much air is required to pressurize the building to 50 pascals, we divide that by the envelope area, which is basically the size of the building. So for example, if this building here needed 10,000 cubic meters of air to pressurize it to 50 pascals, and so that green area, the light green, let's pretend that's 10,000 cubic meters of air. And the dark green, let's pretend that that's 3,000 square meters. We divide 10,000 by 3,000 to get the permeability result. It's a really simple division when it comes down to it. So for you guys, design and as-built guidelines, this is a document that you are reading when you're working out how to achieve your point score. Credit 2.2.3, air permeability performance testing, says this: an air permeability test must be carried out by a suitably qualified practitioner in accordance with the approved standard over a minimum area of the building. The test results must not exceed a maximum air permeability rate in order for this credit element to be awarded. So what do you need to do? If you are getting an air tightness test done on your Green Star project, or if you even think that you might be getting an air tightness test done, you need to find a suitably qualified practitioner. That's what the guidance says. So what does that mean? Who are those people? Where do I find them? So the ATMA website, ATMA is the Air Tightness Testing and Measurement Association. They're a UK-based association, and they've now come to Australia, and we have ATMA ANZ, Australia and New Zealand. However, all of the testing members are listed on this website. Yes, I want to continue. Let's see if I can get to the website in my presentation. There we go. So this little website here has a list of every single qualified air tightness tester in Australia. So you go up to members up the top where that little blue, where it's highlighted here, and you go down to Australia. And it tells you what all the different levels mean. And then down here is all the people that you can call. Oh, look, there's me. Oh, fancy that. And there's a couple on the next page as well. So any of those people are qualified, considered suitably qualified to do your test. This one. All registered testers are permitted to test under Green Star at this point, but I would advise you to check their experience because there is a very broad range of expertise within that list. So you can be a level 1 tester or a level 2 tester or all that jazz, but you can't. Not everyone has got the experience to test complex buildings, so you need to be careful about that. Oh, and when do you call that person? You call that person as early as possible in your project. I would strongly advise you not to wait until the end of the project. My daughter's cleaning a window of the office right there. I'd strongly advise you not to wait until the end of your project to call someone like me, because the thing is, as you go through, it's harder to fix problems at the end of a test. It's much harder, and they're usually quite easy to find and quite easy to design out of a building, but you just have to be aware of them before you start your project. The other thing that we will do, even if you don't call one of us, at the very least, I would advise you to do your very own red pen test. This means that there's no light now. This means that you need to draw a red line around where all of the assemblies that you want to pay attention to in your building. So this means wall joins, all the corners. It means all of the window assemblies, any penetration in the building, whether it's for mechanical penetrations, lighting, plumbing, anywhere where there is a break in the building envelope. You need to identify to your construction team early on in the process that is what you are going to be focusing on. And this red pen test separates the conditioned spaces from the non-conditioned spaces from inside to outside. It also separates internal conditioned and unconditioned spaces such as car parks and plant rooms. And it is usually aligned with the thermal barrier or the insulation barrier. So if you keep those three things in mind, your red pen test is a very simple and quick and cheap exercise to carry out on your own. So this is where it gets a little trickier. So under Green Star, the testing requirements say the test may be carried out on a sample area. So sometimes, because you guys are all working on these huge office buildings, sometimes they're too complex to test or too large to test all in one hit. And if that isn't the case, if it's the other barrier to getting accurate testing done in Australia is that the testers don't all have enough equipment to carry out these tests properly on a large building. The equipment isn't cheap, so there's only a handful of testers in the country that have large amounts of fans to test really large buildings. Otherwise, they have to do it bit by bit. So under Green Star, the sample testing must be carried out at a minimum of 2,000 square metres or 10% of the building's total envelope area, whichever is greater. These sample testing areas must include the uppermost occupied floor of the building and be representative of the external envelope construction, including different facade types and building geometries for the building as a whole. So you have to capture the top floor, and the reason for that is because that's where where a lot of the mechanical penetrations are. It's usually a big weakness in the construction of the building. So even if you are only testing a small portion of your building, you still have to test the top floor. And you also have to, if you've got, say, 3 or 4 or 10 or 11 different facades, you need to test all of those. You need to include all of those in your sample because you need to make sure that they are all constructed properly. What does it say on the bottom? Apartments are a different story. So if you're working on a Green Star apartment building, those apartments all are tested. They are tested by compartment testing. So these smaller, they generally aren't tested at the moment as a whole building. These huge apartment buildings, that the apartments are all tested one by one. And the reason why that's done is because they're all single dwellings and they all need to have smoke separation. and acoustic separation and all of those things. So you want to test the integrity of each apartment on its own. Excuse me. So this is the table that is held within the Green Star Design and As-Built Guidelines version 1.2. So I'm focusing on version 1.2 because there would probably be few version 1.1 projects still out there at the moment. I'm assuming. So the maximum score that you can obtain under Green Star for an air tightness test is 20 cubic meters per hour per square meter. 20 cubic meters of air pumped into that building per hour per square meter of building envelope. That is not a really difficult target to achieve. But the thing where I've circled in red is it says this is the compartment testing addition. Little note here. So this says that you have to test a minimum of 2,000 square meters or 10% of the entire building envelope area. That's to get 1 point. To get 2 points, you have to test 5,000 square meters or 20% of the total building envelope area. When you've got a clown for a daughter. So in order to get the normal and best practice points, you are still allowed to do a compartment test under these Green Star guidelines, but the amount of area that you have to test is much larger. What constitutes a meaningful air tightness test under Green Star? So I've drawn some little diagrams here, which are meant to represent the different types of tests that we can do. So that little red box in the corner there that says 50 pascals, that's my compartment. So let's pretend for argument's sake that is 2,000 square meters of the building envelope area, or 10%, whichever is greater. Pretend that. So we've got a fan or a couple of fans and we've put it in that room and we're testing that room because it's quicker, the building is too large, I don't have enough equipment, whatever reason. So all of the arrows around that box are showing you where the air is leaking out whilst that room is being pressurized to 50 pascals. So all of those boxes around the edge where there's some question marks, there's air leaking into those internal rooms. So the thing about air tightness testing is what we want to test is the external envelope, that dark green section on that diagram that I showed you earlier. We don't want to test the internal walls or floors, and this could be an elevation or a floor plan. It doesn't matter. The principles are the same. We don't want to test between floors or between rooms. We want to test the external envelope. So the amount of air required to pressurize that room is going to be a lot higher because we're testing internal surfaces as well. We're not only testing what's leaking out into the atmosphere, we're testing what's leaking out into the rest of the building. So these types of tests are extremely useful because they tell you a lot of really good information about where the air leaks are coming from. Unfortunately, they don't give you a result that you can compare to other buildings. So they are suitable for things like isolation rooms in a museum if there are usually some quite strict air tightness requirements due to moisture control, in their storage areas, apartment buildings, comms rooms, those sorts of things. This sort of testing is really useful because you are actually wanting to test the integrity of just that room. But if you're testing an office building and you're only testing a small portion of it, then the information that you get, the numbers that you get, aren't necessarily, or they're not useful. But this sort of testing is more accessible in Australia. It's usually cheaper because it is quicker. You're testing a smaller portion. I've written easier, but it's not actually easier because when you're testing only a small portion of a large complex office building, there are mechanical systems and risers and all sorts of things that complicate the preparation of the building. So there's a perception that doing a small portion of the building for the lowest possible score just to get a point is the easiest way to do it. Unfortunately, that's not the case. It's actually easier to test a whole building that's got a better integrity, that's more airtight. Much easier, much quicker, and cheaper in the long run. So I get a lot of people coming to me saying, "Oh, we just want a point," but it's unfortunately it's not as straightforward as that. It's definitely doable. It's just more complex than is commonly understood because of these internal areas and leakages and the extra preparation time it actually takes. Basically a building is a whole system and should be tested as one. And the point of Green Star is to make better buildings. So doing tests like this, you're not really testing the performance of the building. You're testing the performance of a part of a building, and doesn't really guarantee you a better building in the long run. So this was an example of if anyone from Adelaide recognises this picture, this was the results from a test that we did on the middle building. And this was done before, this has all been refurbished now, this development. This is the old Royal Adelaide Hospital development, lot 14 in the city. We tested these buildings before they were refurbished. So the builders and the ESD consultants wanted to know exactly where they stood before they started work, and that is an extremely advisable course of action. I think it was excellent that these guys did this because then they knew exactly what they were up against when they went ahead with their refurbishment. So this is a compartment test. We tested because the building was quite leaky because it was built in 1920 or something like that. It was quite leaky, so we had to do this one level by level. And you can see that the airflows were really high for each level, even though the surface areas of each level were quite low. We needed a lot of air to pressurize them, and the results were very high. But that was all because of internal leakage. All of the vast majority of the air leakage calculated or included in these airflows here was between floors. And as you can see, the results, the permeability, the maximum permeability required to get a score in Green Star, to get a point in Green Star, is 20. And this is an old building, but these scores are off the scale. And the reason is because, like I said, all of the internal leakage was being measured, and the internal surfaces aren't included in the envelope area calculation. A guided test is another option for a compartment test. If you want to test a small portion of a building, you can do what's called a guided test. So what that means is you pressurize to 50 pascals your compartment, and then you pressurize the surrounding compartments so that you're actually neutralizing the leakage between the internal surfaces. If you're only able to test a small portion of a building, this is the only way to get an accurate number. Because as you can see at this barrier between the red and the blue, there's no air leaking between those walls because it's neutralized. The air's pushing up against each other and cancelling each other out. The only air that we're measuring is this air going out to the atmosphere, which is great. You need a lot more equipment to do a test like this though, because you need fans here, and you need fans here, here, and here, and then above that floor, below that floor, you need to make sure that all of the internal surfaces are neutralized. So again, you've got complications with internal risers, mechanical systems, and the additional requirement of all of the additional equipment and setup time. So you get good numbers out of this test, but it's usually cost prohibitive. Sometimes though, this kind of testing is necessary because some buildings don't actually have openings between rooms. I've got a job at the minute where there's a building and it's 3 compartments and there's no door between each one. There's no door between each of the 3 compartments. So that requires a special kind of strategy to test that building. Whole building testing is the best way to get an accurate number. So when you're talking about scores, whether it's 20 cubic meters per hour for your 1 point, whether it's 5 cubic meters per hour for 2 points, or 2 cubic meters per hour per square meter for 3 points, this is the best way to plot yourself within that range. So this is definitely the highest level of accuracy, And you can compare yourself to other projects internationally if you do a test like this and you get the right number. And this is also the best way to ensure that you are getting a better building. So, as I said before, that list of testers are all technically qualified to do this sort of testing because testing in Australia is still very new. The skill set is still being developed. So not everyone on that list is going to be qualified to do a test like this. So you just need to make sure when you approach your tester that they have done stuff like this before and they know what they're doing. Large amounts of equipment can be required, which also can be a prohibitive factor, like I said, because it's expensive. Not everyone has the right amount of gear. Setup can take an entire day and has done. It's taken more than an entire day for really large buildings. I did a test in Sydney earlier this year, and that setup took us well more than a day. So these tests aren't quick. They don't come. You don't kind of come in and out within a couple of hours. And that goes for compartment tests and guided tests as well, depending on the job. It's quite labour intensive. But yeah, if you've had a good air tightness strategy from the beginning and it's not very leaky, and we can predict our equipment requirement on a lower level of air leakage, then it gets simpler. This was an office building that we tested a couple of years ago in Adelaide. It shall remain nameless for the moment. Got something happening on my screen here. I won't tell you which building this was, but it was a new Green Star building in Adelaide. We had a total envelope area of nearly 2,900 square metres, and the cubic metres required to pressurise that entire envelope area was 17,254. So their result was around about 6, a permeability of 6. So they just missed out on, with a score like that, they nearly qualified for 2 points. Not quite. I guess that's all I have today. I was going to say something else before, but I have forgotten what it was. I guess if anyone has any questions, I'm happy to hang around, and hopefully one of you will trigger my memory and I'll know what I was going to say. What have we got here? Oh dear, we've had internet issues, we had Jess isn't organised issues, had issues with flies. It's just not been smooth this morning. Okay, doesn't look like there are any questions, just a few comments on some issues with the audio. My email address is air@suho.com.au, so if you have any questions around Green Star air tightness testing, then please